Okay, so we're going to calculate our pH after I add 10 milliliters past my equivalence point. So, how many milliliters, or how many liters is my equivalence point?
0.76.
Okay, it's 0.76. 0.76 liters is my equivalence point, plus 10 milliliters half that, past that.
Which is
0.01.
So,
I'm sorry. This is going to come into play after when we calculate the total molarity. Let's just start with let's just start with the BAA table. Okay? So I have CH3COOH plus OH minus water CH3COOH minus. Okay. All right. So, what's my initial moles here? 0.00575. And now I need to calculate how many moles of OH I added after I'm sorry, I'm getting glitched right now.
10 milliliters after your equivalence point. So if your equivalence point is 760 milliliters, you want to add how many now? 770. So you would want to find the amount of moles to right then that is going to be added in base. So you're going to have some left over of base, right? We know that we're at least going to be having a leftover amount that is 10 milliliters of whatever my molarity of base is. At least that amount will be left over in moles. So you can kind of jump straight to that, or you can do the full thing out and find 770, and then put the number in here, take the difference. Will still be the same as just taking 10 milliliters of your base and writing it right there. Because you know this is gone, because we're past our equivalence point, right? And that'll also help us solve for how much is there.
Okay.
So, go ahead.
Sorry, I just barely made this problem and I didn't show all my work on my paper, so we might have to work through this one together. I'm going to have to calculate it as we go.
Yeah, I'll do it too.
Okay, so you guys were right. I have 760 milliliters plus 10 milliliters is going to be 770 milliliters, which equals 0.77 liters. Now I need to calculate how many moles of OH are in those 0.77 liters. I know my molarity, 0.0076 equals 0.77 over X. Someone saw that
Let's
out?
do that. See if you get what I got.
0.5852.
Yep.
0.00585.
52.
Okay. This doesn't matter. Okay, so now let's do this. Okay. This is obviously a bigger number than this. So what is this subtracted by this? How many am I going to have left over?
1.02 times 10 to the negative 4th.
1.02 times 10 to the negative fourth. And how many moles of acetate am I going to have?
0.00575.
Yep, 0.00575.
75.
The same amount, because you can only form as much as your conjugate base as you had acid, right? So this is kind of one of those times, again, where we have moles here, we have moles. So is this one, did you make this so that they could just go straight through?
They should be able to.
Okay, so this is kind of one of those cases. I know some of you have classes, but what we'll do is, at the end here, where you can literally just put this into molarity by understanding the total volume that you added. Because didn't we start off with 25 milliliters of this? We just added 770. So we're going to do that. We get 795. We have 795 milliliters. We're going to solve for molarity of this. If we take the negative log of this, will tell us our POH. We take 14 minus that. We can get a pH directly. Now, what we're saying is, in this case, I think he said he made the problem so that you could kind of just go directly off of the leftover strong base and get the pH, because the conjugate base is such a weak base, it's going to contribute to the basicity of the solution very little, almost negligible, right? But the key is I would always do it out still. I would always take my conjugate base, also put that in molarity, and do a new ice table to solve for how much OH minus does that contribute to as well, and add the two at the end, and take the negative log of that and the pH, right? That would be the safest way and what I would always do. But this case where we're kind of out of time, you could have you can jump straight here. And I saw you had a question?
Yeah,
Yeah.
you pretty much answered it. So you just have to do a new rice table with the conjugate base, figure out the OH concentration,
Yep.
add them together.
Exactly, and he's whipping that up really quick so you can see it. So that's what you have to do.
Okay.
So this is a really good problem, you guys. It integrates everything. Again, before we hit our equivalence point, we use the Henderson-Hasselbalch equation after our BAA table. Once we're at our equivalence point, right, we are going to lose all of our acid, lose all of our titrant, and just be left with conjugate base. So we do a BAA table, then take our conjugate base and put that into a rice table to get the pH. And it should be above 7 if we're taking a weak acid and titrating it with a strong base, which we got. After equivalence point, we get this whole setup where we are left with a little strong base after. So that's why in our titration graph, our pH is approaching the pH of a strong base. It's approaching this amount because we're getting to the point where we're just having all this left over. We're basically the pH of just a solution with just this in it because there's so much of it getting left over now. Okay? Hopefully that makes sense. Couple questions up here.
So do you use that same KB when you use the rice table?
So the same KB, exactly. And then there was one other question up here. Yeah?
What was the number of moles of the CH3COO minus?
Right here?
00575.
Okay, so if we think about this, look at this reaction right here. What's happening is this reacts with this to produce these two. Before equivalence point, what's my limiting reactant? My OH minus. I can only do this reaction before equivalence point as much as my OH minus is there because it is this molecule that comes over and stills the H. So I can only form as much of its conjugate base as I have this one to reach over and still it. But after equivalence point, I have plenty of this, and I can only form as much of this as I have this available to let the OH still it and get over there. That's why those numbers before is the same as this, but after equivalence point, it's the same as your original. Right?
Ice table, why is the molarity of the acid the same as the moles of OH in the air table? Like,
Yeah, I didn't get that number either.
Over here?
Yeah. I think that's
Let me see. What was this in molarity? Sorry, I
Well, it's 0.0575 divided by 0.77, right?
0.795.
Where's that?
Because you have to add in.
Oh,
Because it's 25 milliliters plus 770 milliliters.
plus 770. Okay, we're gonna talk about this.
Okay. But I did it out, you guys, and this was like 10.01 and this was like 10.1. So really, like I said, the weak component doesn't do much, but if you really want to be thorough, then you can go ahead and go through and do it. Okay. Is there any more questions before we stop the review? If not, you guys can come up and ask your individual questions. Yeah, Mitchell?
So do you add the two OH concentrations? Or do you put the OH in the rice table over there?
Yeah, so I just did it